Hey, it's Mrs. Moret. I am here to go over your Unit 3, quiz number 3 review, and it's all on solving quadratic equations with real and complex solutions. So to get started on number 1, talking about how many solutions an equation has, and then are they real or non-real or complex. And then it says, explain how you know without solving completely. And that is key. When that's in the directions, you really have to do that. You can't just go solve it and say, well, I found 2 or I found 1. You have to actually show that you understand why there's a certain number of solutions. So that brings us to the quadratic formula. In our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's the part that's under that square root called the discriminant. That's what we use to know how many solutions there are and then whether they are real or complex. Okay? So what we really want to know for number 1 is what is the value of just b squared minus 4ac. Okay? If we can find that, then we can answer how many solutions. So for all 3 of these are already set equal to 0. And so I can go ahead and evaluate the discriminant. So b is 4, 4 squared minus 4, a is 1, and c is 2, times 1 times 2. And on my calculator, I get 4 squared minus 4 times 1 times 2. Oh gosh, what am I doing? Try it again. 4 squared minus 4 times 1 times 2 is 8. So since this is equal to 8, and that's a positive number, when we square root, we're going to have the positive square root of 8 and the negative square root of 8. So that gives us 2 solutions. And since 8 is positive, those are real solutions. So this is 2 real solutions. I'm just going to write 2 real. And the reason why is because that's a positive number. On part B, so b squared minus 4 ac, again, b is negative 8. So we need parentheses when it's negative. Negative 8 squared minus 4, a is 1, c is 16. And I'll put that in the calculator. Oops. And I get 0. So remember, if this is equal to 0, and then it's going to be under a square root. So 0, the square of 0 is 0. It's not positive or negative. So it's only going to give us one value. So since this is 0, there is one real solution. And then finally, on our last one, b is 6. So we have 6 squared minus a is 1, c is 25. So 1 times 25. Okay, so 6 squared minus 4 times 1 times 25 is negative 64. So now, again, this would be square rooted. And so we'll have 2 different square roots, the positive and the negative, but they're both going to be imaginary. So our solutions are going to be non-real or complex, but still 2. So since this is negative, they are 2 non-real solutions. Or you could say 2 complex solutions. All right, number 2, the solutions to x plus 4 squared equals 25. So to think about it, x plus 4 squared is a parabola, and it will equal 25 in 2 different places, so we should expect 2 solutions. We find those by square rooting each side. So the square root of this is simply x plus 4. And I'm going to have the positive or negative. So that's why we get two solutions, square root of 25. So the square root of 25 is 5. So I have two equations to solve. X plus 4 equals 5. And x plus 4 equals negative 5. So subtract the 4, and we get 1. And over here, when we subtract the 4, we get negative 9. So two real solutions there. Whereas on the next one, we're going to follow the same process, but this time it's equal to a negative 81. And so this is going to have imaginary or complex solutions. But again, you would square root, and the square root of 81, the square root of 81 is 9. So the square root of negative 81 is 9i. So we're going to have, when we square root both sides, we're going to have x minus 8 equals the positive or negative square root of negative 81. That means x minus 8 equals positive or negative 9i. And then we're going to add the 8 over. And our final answer is x equals 8 plus or minus 9i. So two complex solutions, 8 plus 9i, and that is D. And 8 minus 9i, which is F. All right. Number 4 on the back side has, we have to solve or look at someone's work where they have solved two different equations, finish each student's work and state the solutions. So student number one has used the completing the square process, and student number 2 has used the quadratic formula. So we're just going to pick up on their last step. Here we're going to square root both sides of the equation. So x plus 2 equals the positive or negative square root of negative 16. And again, since the square root of 16 is 4, the square root of negative 16 is 4i. So x plus 2 equals positive or negative 4i. Move the 2 over by subtracting. X equals negative 2 plus or minus 4i. Okay, and so student number 2 over here used the quadratic formula. So 16 minus 80 is what I do next, which is negative 64. So I get negative 4 plus or minus the square root of negative 64 over 2. And then the square root of negative 64 is 8i, since the square root of 64 is 8. So this is negative 4 plus or minus 8i divided by 2. Then last step is to distribute the divide by 2. So negative 4 divided by 2 is negative 2. And then 8i divided by 2 is 4i. So it looks like in each of these strategies, the students' final answers are actually the same. All right, number 5, we're solving quadratic equations, and then we have to solve at least one using the quadratic formula and at least one by completing the square and show our work. So I'm going to complete the square on A. I'm going to start by moving the 15 over. So I have x squared minus 10x plus blank equals negative 15 plus blank. And then I think about, okay, I've got x squared minus 10x. This will be a negative 5x in each of those spots. So thinking about what value completes the square, and it looks like it's going to be 25. Okay, my next step then is to rewrite x squared minus 10x plus 25 in factored form, and then also combining negative 15 plus 25. That's 10. And then in factored form, this is x minus 5 squared. Okay, so now square root. We're going to have real solutions because I'm square rooting a positive number. X minus 5 equals the positive or negative square root of 10. 10's not a perfect square, so now I just add the 5 over and I get x equals 5 plus or minus the square root of 10. The next one, I'm going to solve using the quadratic formula. It's already set equal to 0, so a is 1, b is 3, c is 28. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, that is equal to negative 3 plus or minus something over 2. I'm using my calculator to find 3 squared minus 4 times 1 times 28. I did it all in one step, and I got negative 103. So what that tells me is that these are going to be complex solutions. I'm going to simplify a tiny bit by saying this is negative 3 plus or minus. You can have your I first or your I after. I'm going to put it first today. All divided by 2. Last step, divide each part by 2. It doesn't divide evenly. You could have negative 3 over 2. You could have negative 1.5 here. They're both the same. Either way, plus or minus I root 103 over 2. And again, your I could be at the end. Just make sure it's not under the radical. So before or after, but not under. Okay, almost finished. Here we are with part C and then part D. So on part D, I'm definitely going to use the quadratic formula for that one since my A value is not 1. Makes the quadratic formula easier for that. Part C, you could use either one. I'm going to complete the square again, even though it's not like my favorite to do if this is an odd number. But I'm going to go ahead and complete the square. So move the 28 over. X squared minus 3x plus blank equals 28 plus blank. And I'm going to just use my little box here to figure out what goes in the blank. So we have x squared and then negative 3x, negative 1.5x on each of these diagonals. So they add up to negative 3 and they're exactly the same. So x, negative 1.5, both of those. And then negative 1.5 times itself is equal to 2.25. Okay, so that's what goes in the blank. 2.25 here and here. Okay, rewrite in factored form, x minus 1.5 squared, and combine 30.25. Okay, now I'm going to square root both sides, and then final step would be to add the 1.5 over. Every once in a while, when you get a decimal like that, it actually is a perfect square. And that happens this time. So that's kind of cool if you didn't know that. The square root of 30.25 is 5.5. So when I square root both sides here, I get x minus 1.5 equals the positive or negative square root of 30.25. Oopsies, missed the 0, 30.25. And that is equal to positive or negative 5.5, as I showed you on the calculator. Okay? So last step is to add the 1.5 over. So I'm going to say x equals, I'll set up two equations. X minus 1.5 equals 5.5, and x minus 1.5 equals negative 5.5. Okay, so I solve both of these by adding 1.5, and we get x equals, this is 7, and over here, x equals, this is negative 4. Oof. Okay, there we go on part C. And then I'll leave that there for a second. You can always pause the video and look at my work to figure things out as you're studying. A good strategy. And then part D, I said I am definitely going to use the quadratic formula because of that 3 in the front. So A is 3, B is 9, and C is negative 3. So x equals negative 9 plus or minus the square root of 9 squared minus 4 times 3, oopsies, times negative 3, all over 2a, 2 times 3. So negative 9 plus or minus the square root of something over 6. So I'm going to evaluate 9 squared minus 4 times 3 times negative 3, and I get 117. 117 is not a perfect square, so I'm going to leave it under the radical, but it's going to be a real solution, right? 2 real solutions because 117 is positive. And so the last step would just be to split apart the divide by 6. Negative 9 divided by 6 is negative 1.5. And then the square root of 117 over 6 would stay like that. Final answer. Okay, last but not least, use the graph to answer the following. Given the equation, 2x squared plus 6x minus 2 equals blank. Fill in the number for the box that would cause the equation to have 2 real solutions, 2 non-real solutions, and 1 real solution. So for 2 real solutions, you could have the equation equal to any value above this. This is like negative 6.5. All right. So right here, the vertex is negative 6.5. And so any value above that is going to have 2 real solutions because it will cross the function in 2 places. So my example here is 1. Okay, so this is the line y equals 1. It crosses 2x squared plus 6x minus 2. That's this parabola, y equals 2x squared plus 6x plus 2. Okay, so again, any value above negative 6.5 will give us 2 real solutions. Okay, any value below negative 6.5, like maybe negative 10. So this is the line y equals negative 10. We can see it doesn't even touch the parabola. And so we would have 2 non-real or complex solutions. So I'm going to say negative 10 for that. And then finally, one real solution, that's this negative 6.5. The vertex is right on that line. So negative 6.5 would give us one real solution. All right, so that is the end of your quiz review. I hope you found the video helpful, and I'll see you when you're ready to take this quiz.